which I'm sure you've seen before, this curve here, which means that under here, what this means, this is the mean here, this is the number of standard deviations each way, and what it's saying is that this is the probability is the area under the graph. So if we want to find the probability that a thing is one standard deviation on either side of the mean, then we would find this area here. And so you can see there's a lot more things in that area. So that's because there's a lot of different effects on the tomato who've acted in different, and some have cancelled each other out, so that you end up with an average sort of tomato here. But down here, you can see there's not much area under the graph. This is a very scrawny tomato, and that's because lots of bad things have happened to it and not many good things have counteracted it. And that doesn't happen that often, because mostly the good and bad things sort of even out, and so we end up with a really small tomato, but not many of them does that happen to. It's just some of them. And the same as here, you only get one or two really, really big tomatoes, because all of the good things have had the right sun, the right water, whatever, happy bee and so on, things like this, and so it's turned out to be a really big tomato. So that's what I'm talking about, the individual effects. Okay, now I've tried to make sure that we stick to examples other than this tomato one, though that does actually apply in business as well, because if you're trying to send things off, if you're exporting or whatever, it's very important that you can control the size of things. So it does come into business. But what I want you to do is have a look at these things here and have a think about which of them would you expect to be able to approximate with a normal distribution. Okay, so I'm not saying these follow the normal distribution, which is what we tend to say, but isn't really accurate, because what they do is they do what they like, basically. So it's not an a priori. I wonder if it is. Have a think about this one. So the normal distribution is approximating this behaviour. So write down what you think, if you think they'd be normal or not. And I'll find my own answers. Okay, there may be some of you, and it's quite all right to be like this, who've always thought that a 10 kilogram bag of flour had 10 kilograms of flour in it. You would think so, because that's what it says. But that's not true. 10 kilogram bag of flour will have anything between 9.9 or 1 point quite a bit more flour in it. Can anyone tell me why would that be? Why does it not have exactly 1 kilogram of flour in it? Pardon? Uncertainty. What sort of uncertainty? What sort of things are going to affect how much flour is in that bag? How's the flour going to get into the bag? Okay, first of all, we have a machine that's milling the flour and it's coming down. We've got the bag sitting there and it just goes into there. Okay, how accurate do you think that machine's going to be? Well, it could be quite accurate and get exactly 10 kilograms. But even then, there's no such thing as exactly 10 kilograms. Does exactly mean 10 kilograms plus or minus 1 gram, or plus or minus 1 kilogram, or whatever? So to start off with, what do we mean by exactly 10 kilograms? Okay, now there are precision things that can measure to the nearest gram. And if we were sitting there with a precision instrument and a person or whatever, we could sit there and make sure that we got 10 kilograms to the nearest gram in every 10 kilogram bag of flour. Okay, why would this not be a smart idea? Yeah, it takes too long. It's really, really expensive. And so you only measure to the level of accuracy that it's worthwhile. So rather than having somebody making sure there's exactly 10 kilograms of flour, you have these machines that put in about the right amount. And generally, they try to put them over. Now, have any of you tried the chicken enchilada packs that you get from was it that yellow box with the red on it? Old El Paso, that's the one. Yep. Okay, now in Old El Paso enchilada kits, they say that you get 8 corn thingies, 8 shells to wrap your enchiladas up in. Now, I've noticed that most of the time you have 9, occasionally you have 8, and the other day I had 10. So what's going on there? Can't they count to 8, putting enchilada shells into a packet? And the point is that they have a machine that mostly gets 8 in there, and they probably do it on weight. And if they're a little bit light, they might end up with 9 in there, or even 10 if they're very light. And it's more important that they don't waste time having somebody individually counting out each enchilada thing to go in there. So it's a matter of whether the accuracy is worth the money that it's going to be put into it. Okay, so this one here, weight of flour in a 10 kilogram bag, I would say yes, it probably is normal. The mean, I would guess, is probably not 10 kilograms, and we'll come to that in a few minutes, is that in manufacturing processes where you have to meet legal requirements, you would not put your mean at 10 kilograms because half of your bags would then be underweight. You have to put your mean a little bit higher so that mostly they're not going to be underweight, because if you have too many underweight bags, then you get taken to court and prosecuted because you are selling things that, whatever, you're lying about what you're selling. Okay, number of children in a family, would that follow a normal distribution? Hands at those who say yes. Hands at those who say no. Okay, you're right with no. In a family. Well, actually, that's not true even then. So it's no for several reasons. One, it's discrete. You don't get half children. Okay, and the other thing is that there is a much bigger spread above the mean than there is below it. Okay, what's the mean number of children in a family in New Zealand? Does anyone know? I think it's just about 2, is it, or slightly more than 2, or something like that, then below it. Okay, let's draw a distribution of the number of children in a family. Okay, we don't know whether you count 0 or not really, do you? Okay, so we've got 2 is the mean, okay, and then we have maybe maybe even more people with 1. And then you can have 3, and you can have 4, you can have 5, you have the odd with 13 or 12 or something like that. So you can see it's not normal because you can't go below 0, the mean is around 2, and you can actually have quite a high tail. So that's not really easily approximated by the normal distribution. Okay, what about number of biscuits in a packet? Okay, there are some packets for which this is certainly not true. You can tell me a kind of biscuit that it's not true. What? Sesame oil. Why would you say that? They do vary. So that might be normal. That might be noted in normal, yeah. Okay, what about toffee pops? How many pops in a packet? 16, isn't it? Or is it 12? I think it's 12. Okay, how many Tim Tams? I think it's about 12. Not that we're counting or anything like that. But so in chocolate biscuits, it's not a normal distribution. So it depends on the packet. So it may be that for something like sesame oil, where they're thin and you can fit lots in, or especially those farm bake ones, you know, where they come in bags, and especially if you have a large one, then it might be a little bit closer to normal. Okay, volume of juice in a container. Hands at those who think it could be normal. You're correct. Yes, it is. It's like the flour. Things like that are clearly continuous. You see, children and biscuits are not continuous. They are discrete. Flour and orange juice are generally continuous. Okay, house prices. Same problem as above. House prices, you have a very long tail. Okay, so you can have your median house price at the moment is about $350,000 in Christchurch, and you'll have a few down to about, say, 200. There's not a lot you can get under 200,000 at the moment, but you can get houses which cost $1 million or more. So you've got a really big tail up to the right. So no, you can't. It's not a normal distribution. And that's why when they're talking about house prices in the media, they talk about a median price rather than the mean, because the mean does not occur in the middle. And the weights of New Zealand males, that's probably quite good to approximate near the middle, but again, you'll have there's a bigger range upwards than there is downwards. Because you've got this lower level, nobody can weigh less than 0, and in fact nobody can weigh much less than probably about, I don't know, an adult male shouldn't weigh much less than 50 kilograms. And so you've got your average at maybe, say, 80, but you have people who weigh up to 200 or more kilograms. So it's not. So, no, again, bigger spread above. Now, having said, even though these things are not always exactly approximated by the normal. Exactly approximate is an interesting terminology in itself.